कैमरा वाला होता है कैमरा वाले का मतलब साइड में जाएगा कुछ
Are either of you, are any of you giving talks for
this
the
will wind
T-5?
up on the NSS website.
Okay, thank you.
So keep that.
Okay, I'm going to, if someone shows up for the T-5, I have like 5 presentations ready to go, but I need people to give them. In the meantime, I'm going to talk about the Planet Moon project. The Planet Moon project is the idea that we're going to transform the moon into an inhabited sister planet of the Earth in this century. By doing so, humankind will become a multi-world species. This is our future home in space. We're going to have, by the end of the century, we're going to have tens of thousands, hundreds of thousands, perhaps a million people living on the moon. Why do we go to the moon? We have desire to explore, to gain knowledge, and to perpetuate humankind. The moon is nearby. It's a lot closer than Mars. It's a lot closer than Asteroids. It has resources, and it will be the stepping stone to all of our future efforts in space. The Industrial Revolution began when we had a link between human expertise and the limited resources of Earth. So, very important, we have limited resources here on Earth, but when we had the Industrial Revolution, our expertise grew to the point we could build a steam engine. We had access to iron ore deposits and coal deposits, so we initiated the Industrial Revolution. We're still living with that. But in the year 2013, we have what I call the closed Earth mindset. We have limits to everything, to land, population, energy, mineral resources, water. We have limits to growth because of all of these things. So we're confined in our thinking. When we go to the moon, we're going to make an amazing discovery, and that is that we have access to the unlimited resources of space. There are far more resources on space than we could possibly ever use here on Earth. And so the closed Earth mindset will give way to an open space mindset. And we will be able to conduct large-scale operations in space. We will explore the solar system in depth. We will conduct planetary engineering exercises like the planet Moon, planet Mars, perhaps Mercury, Venus, and other places in the solar system. And we will initiate missions to the stars. The moon has a lot of resources that we need. We can use those immediately. It has oxygen, silicon, iron, calcium, magnesium, aluminum, titanium. It has water and hydrocarbons at the poles. It has an unlimited source of energy from the sun. The sunlight is unobstructed and it's constant, and it's abundant. We get 1.3 kilowatts per square meter. So, what we have done over the last 50 years is we've done the exploration and characterization phase. We've done the science of the moon. We've taken photographs, we've analyzed the lunar regolith, the soil. Now we'll be ready to begin the second phase, which is to start using the lunar resources. So that's insight to resource utilization. This is the Lunar Reconnaissance Orbiter, for example. It's done a very good job. Now we're ready to move on to the next phase. So the Planet Moon project, the next phase will be to begin with the first base, then we will build a local network of bases, and then we'll expand this network over the global structure of the moon. First lunar base. This is an image of the south pole of the moon. The geographic south pole is at the rim of Shackleton crater. Highlight the massive called Mons Malapert, which is highlighted in yellow as the site of the first lunar base. It's about 150 kilometers from Shackleton, and its Earth is to the top of the slide. You can notice all the craters in this area is heavily cratered. A lot of these craters are cold traps because they don't see sunlight, so they have resources such as water. This is a blow-up of Malapert, the Mons Malapert. This crater that's highlighted in the center is about 1 kilometer in diameter for reference. Malapert has the advantages of continuous communication capability, and it has access to sunlight for 85 to 90% of the time. This is a picture of the South Polar region of the moon taken by the Japanese satellite. Shackleton, the geographic South Pole is noted, and Melbourne, you can see the south face of Melbourne is illuminated. And there's this Earth in the background. So you can see from Melbourne, you will always have the Earth in view, and you can see Shackleton. It's a very prominent structure. And we can put command and control centers on the summit of Melbourne and control this whole South Polar region because of its elevation. This is an interesting slide that shows the meteorite impact history of the moon over the last 8 years. There's a lot of meteorites, a lot of near-Earth objects that impact the moon. The same thing is happening to the Earth. But as you can see, the polar regions are spared. There's no recorded events in the polar regions. So this is another reason, another advantage of going to the polar regions. Of course, I like the South Pole. We're going to deliver to the first lunar base robotic systems, communication systems, solar panels. We have the means for doing so. Many governments, countries have rocket systems that can go to the moon. The key here is additive manufacturing or 3D printing, but we're also going to do have excavators, transporters, processors, and so on. What we have done so far is what you would call a linear phase of exploration. We start with the spacecraft, we launch it, it goes to the moon, it has a mission, and then it ends. But now with additive manufacturing and going to the moon using resources, we're going to go into exponential growth. Because we will have machines that make solar panels that give enough energy to make more machines, to make more solar panels, and so on. So this is going to be a really dramatic advance in space exploration by going to the moon and realizing exponential growth. Sorry, I hit the wrong button here. We're going to do milestone experiments with in situ resource utilization. We'll make the first solar cell, the first brick, the first transistor, the first wires, the first I-beams, and so on. I'm going to predict that the manufacture of the first solar cell that produces 1 milliwatt of power will be a breakthrough milestone that's equivalent to the steam engine or the first aircraft flight or something equivalent, because this will show that we can produce energy in space from space resources. This opens up all space to human exploration. This is how we're going to control devices on the moon from Earth. It shows you what some of these robotic devices look like, kind of all these drawings. The bootstrap manufacturing, as I mentioned, we can put like 40 metric tons on the moon, and these devices will be teleoperated, but they will be self-replicating and then grow infinitely. We have free real estate on the moon. We have abundant energy and resources. So that's going to make all this possible. There's a prediction that the manufacturing capability, when you use small machines to build the components of larger machines, and those larger machines build components to build even larger machines, that we will be able to develop a lunar manufacturing capability on the moon that will exceed that of the Earth. That's a pretty dramatic statement, but that is entirely possible. Once we have a lunar base, the robotic base will build habitats for humans, and we can start having an Earth-Moon biplanetary commerce where people are going in this figure 8 orbit system. We have regular commerce between the Earth and the Moon. This shows what a habitat might, or what a orbiter might look like for humans. See the Earth in the bottom here, and it's going around the Moon, going between the Earth and the Moon in a figure 8, which is the symbol of infinity, interestingly. We're going to commission the first base, oversee science and development projects, have an industrial park. This is a very interesting discovery on the moon. Here is the roof of a lava tube. This is about 60 meters in diameter and about 80 meters deep. And underneath there's a large cavity where you can put, say, inflatable habitats, and you supply it with energy. And this would be a perfect place for humans to be protected from micrometeorites, temperature extremes, and the radiation from space. So we can go into our second caveman epic. We were cavemen, 40,000, 50,000 years ago? Well, we're going to do the same thing again on the moon. But it's a ready-made habitat, or a shelter, rather. So this is what it would look like. We go underground and we have an inflatable habitat, and we can have palm trees and pleasant settings. More underground habitats on the moon. We go underground to protect ourselves from the hazards of space, because space begins at the lunar surface. Here depicts people on the moon controlling robotic devices on the surface. What what processing might look like on the moon. Now we're going to expand the lunar base. We're going to build an electric grid, solar-powered electric grid that goes around the circumference of the moon. We're going to build railroads on the moon. So we want to go around the circumference of the moon. The reason for that is that once you go around the circumference of the moon, you have solar panels all the way around that have continuous power. You have 50% of the solar panels will be in sunlight all the time. We'll do this at first at 85 degrees south latitude, and then in parallel with this electric grid, we'll build railroads, pipelines, telecommunication systems, and so on. And this is a pattern-length drawing. This might be what it would look like when we're building out from the base, so we're going to go all the way around the circumference. And this being perhaps equivalent to the transcontinental railroad development that we did in the United States in 1867. It would have a golden spike that we can put in when we connect the two limbs. This is what the first railroad might look like, solar-powered and tele-operated. We'll construct a local network of lunar bases. The yellow lines are the railroad system, but you'll also have a power system in parallel with this, as well as pipelines, and have a cable car from Mons Malapert to Shackleton. And we'll take advantage of all of the resources that are in the cold traps, and we'll set up telescopes and so on. We'll have a community of people we can support here nicely, because these solar panels will generate hundreds of megawatts of power continuously. So people from any nation can fly here, land, and plug in to the electric power network, and we're going to have an autonomous, functioning municipal setting here where people can live indefinitely on the moon and be highly productive. It shows what an underground mall might look like, human-powered flight. This is an agricultural module showing a robotic device here pouring coffee for the person who's watching the harvesting. Another underground mall, human-powered flight. We're going to import all the things we want from Earth, but we're going to leave the mosquitoes and the scorpions behind. Railroad operations on the moon is what it might look like fancifully. Probably never looked like this, but that's what artistic license is for. And we'll have magnetic levitation capability. This will be a maglev train that can zip along on the very flat equatorial mare areas. This might be able to go 1 kilometer per second. There's no air resistance, so these can zip along from one place to the other on the moon at a very high speed. So we can go from the South Pole to the North Pole in a very short time. Shows sightseeing on the moon, more railroad operations on the moon. This would be railroad transport from the South Pole on the right across the equatorial mares in the center and all the way up to the North Pole. So we'll have a global human presence on the moon, and we can expand out from this railroad to all the areas of interest for scientific purposes, development purposes. We can have cities on the moon, and the moon will become an inhabited sister planet. One of the big advantages of going to the moon is it is an ideal place to gain access to space. We're going to build mass drivers. These are the same technology that's used for maglev transportation, maglev trains. Like there's one in Shanghai that I personally have ridden on. This depicts a mass driver that you build a spacecraft on the moon from lunar materials, you put it on the mass driver, and when the direction is, when the alignment is correct, you shoot off the spacecraft. So we're going to build thousands and thousands of spacecraft on the moon. And we're going to launch them to all areas of interest in the solar system. And instead of having one Cassini mission to Saturn once every 15 years, when Saturn comes into alignment, we're going to send off thousands and thousands of spacecraft to the entire Saturn area. We'll do the same thing with all other areas of interest throughout the solar system. The moon will become the hub of space exploration. And one of the advantages of the mass drivers is that you can use mass drivers not only to launch spacecraft from the moon, but spacecraft coming in to the lunar orbit can align themselves with the mass driver and be captured and be braked to a stop. So we can launch from the moon and come back to the moon, on and off the moon, using mass drivers without rockets. And we can treat the moon just like a freeway. We can drive on and off the freeway, on-off ramps. On the freeway, we can do the same thing with the moon. So we're going to have a lot of commerce on the moon, no rockets, just using mass drivers. So we're going to build and launch spacecraft, recover spacecraft. We're going to deliver asteroid resources to the moon. This depicts a manned spacecraft being launched from the moon. This track is foreshortened. The actual track length would be perhaps 100 kilometers long to get to the proper speed. Near-Earth objects are not a threat to the Earth. One of these, this is Gaspra, but if one of these collides with the Earth, it would be devastating. But by going to the moon and building robotic devices that can mine asteroids, we're going to change the threat of asteroids into an asset. We're going to identify asteroids that are coming into or have a risk of collision with the Earth. We're going to go there and mine them, break them up, and use their assets. We're going to deliver the noble metals, platinum, palladium, gold, and so on, to the Earth and to the moon. Remove the threat, and we have an unlimited supply of minerals and elements to the Earth and to the moon. This shows the lifting body coming back into the Earth with valuable metals. Perhaps you can make the whole spacecraft. The whole spacecraft would be just made out of pure platinum, for example. It would be shaped into a lifting body. It would come skipping into the Earth's atmosphere and then skid to a stop on a long runway in the desert somewhere.
With a lot of guards.
What?
With a lot of guards.
Yeah. Well, you know, the value of a lot of platinum would go down because we're going to have so much of it. So, but yes, it would be this would be we're going to harvest. We're going to realize a lot of wealth coming to the Earth, substantial wealth coming to the Earth. It will improve the living standards for everybody, and we won't have to dig into the ground to get anything anymore. We'll take all of our resources from space. Mining operations basically will cease on the Earth. We can build solar panels out of lunar material on the moon, launch them with mass drivers from the moon into Earth orbit, assemble them in Earth orbit, and have large solar power satellites that ring the Earth. We'll have, say, hundreds of solar power satellites in orbit around the Earth made out of lunar materials and supply all of Earth's energy needs with clean energy forever. And this would be very inexpensive because the materials from space are basically of so much abundance, they're basically free. It's just the cost of assembling them. So we're going to build satellites, solar power satellites, that are in Earth orbit. Materials come from the moon, they're built on the moon, they're launched from the moon, and assembled in Earth orbit. So we can improve the quality of life for everyone on Earth. We're going to clean up pollution and desalinate seawater, in addition to delivering electric power wherever it's needed, deliver potable water anywhere. Solar sails will be made on the moon out of lunar aluminum. And solar sails will become like the sailing ships of yore. We're going to have solar sails that go all throughout the solar system on exploration missions, cargo missions. We can identify, say, a small asteroid. We can attach a solar sail to it and change its orbit and bring it into the Earth-Moon vicinity where we can harvest its materials. One of the advantages of solar sails is that they can hover above the North Pole or the South Pole of a planet, such as Mercury, so that the sunlight pressure driving the sail up is matched by the gravity pulling it down, so it can be in a hover location. And by being so, it can then act as a communication link to robotic devices on the surface of Mercury in this case. And maybe we can have manned missions to Mercury. This would be a communication link. This shows a solar power satellite being delivered to Mars. We can build solar panels on Mars, send them build solar panels on the Moon, launch them to Mars orbit, assemble them in Mars orbit, and we can ring Mars with solar power satellites that provide all the energy that Mars needs. And so we can have a solar sail and hover orbit above the North Pole of Mars. Then would have a communication link, a continuous communication link with Mars, and you'd have a solar power satellite delivering electric power to the Mars base. So Mars will have communications and power. And by doing this, we can then use the model of the Moon. We can start building an infrastructure on Mars. And this would be the railroad and pipeline structure on Mars, perhaps, where you have cities of these nodes. So we can have a planet Mars the way that we have already developed a planet Moon. So when the first astronaut lands on Mars, she can go into an underground compartment that already has a hot tub of water, and there's a dinner waiting for her on the table. Now we can use high-powered lasers to augment solar sail propulsion, and we can use the solar sails can go from the Earth to the Mars, say in 2 weeks, using augmented thrust for solar sails. And eventually we can use solar sails to go to nearby star systems, and we can start exploring nearby stars. So we're going to go to the Moon. The Moon will become the hub of space exploration, and we can start delivering our DNA in the bottom right-hand corner throughout the solar system and eventually throughout our galaxy. So the Planet Moon Project portends a marvelous future. We're going to have a wealth of energy and materials delivered to Earth. We're going to have an improvement in the living standards of quality of life for all people on Earth. And our human activities in space will be unbounded. So that's the end of my talk. Thank you.